So welcome everyone. Welcome to the session on springs. So already in this series, that is strength of material series, we have discussed three topics, and this is the fourth topic in this series, that is springs. Right, and springs is the one of the most repeatedly asking question topic in GATE and ESE, and one of the easiest topic also. So quickly we can answer, and the error in this topic questions is very less, right? So that's why you can easily score in this topic, and you should not miss this topic in GATE and ESE. Okay, so moving to the our topic. Before that, I need to give you an important information. That is, in the month of June, that is every Sunday. So tomorrow is a Sunday, right? It's a big day because India's largest weekly test, which is going to be happen exactly at 11 a.m. So don't forget it, right? So on June, every Sunday it is happening, and tomorrow also it is going to be happen. That is India's largest weekly competition exclusively for GATE. And before that, means before commencing the examination, 60 minutes preparation will be there. After that, questions will be shooted out in a live, that is, it is typically kind of a original GATE questions, which is picked up by the India's best educators on the field, right? And live test will be there, and leaderboard will also be provided on a live. So you can see that in a live, that where you are standing across the country, competing with the across the minds in the country, right? And most important thing, after completing the examination, for each questions detailed video solutions will be there. So once after completing it, you will get the answer key immediately, so you can revisit your mistakes and you can improvise your mistakes, right? That is very important here, right? Now, how to attend it? It's very simple. Just open the Unacademy app, and you will be prompting this Unacademy comeback in the first page itself, right? While entering, you have to use the code PSK20. If you use the code, it's completely free to attempt this Unacademy comeback. And not only attempting and getting the questions, you'll also get few exciting prizes also. That is, if you get a rank 1 to 3 during the exam, if you get a rank 1 to 3 during the exam, you'll get 1 year free subscription. Okay, you'll get 1 year free plus subscription. From the rank 4 to 10, 75% offer will be provided for the students who get rank 4 to 10, and 50% offer will be provided for the students who are getting rank 11 to 50, and 51 to 100 rank students will get 25% of offer, right? Okay, now from this you may know that it's one of the India's largest tests and more interesting, and you will get the answer, that is answer keys with exciting offers. So hope it is surely useful for you. And these are the students who got R rank under mechanical, protection and engineering science category, and this is for your information. And these students have opted Unacademy as their learning platform, and they have achieved this great height. And there are two types of subscriptions that is available. One is plus, another one is an iconic subscription. So in a plus subscription, you'll be having a live classes, that is, you can access the live, all the live classes that is available in platform under the category what you are subscribing, and crash courses will be there to get a good amount of knowledge or numericals, and at the last minute you will get these crash courses will be helpful to improvise your marks. And weekly tests will be there, that is every week weekly quizzes will be there, so that you can regularly update yourself, find your weakness, and you can improvise it, right? Check whether you have studied it correct or not. So this is a checking part. Every week you will have a weekly test. And doubt solving, that is every fourth session is a doubt clearing session. So which means your doubts will be clarified immediately. It's not a lengthy thing, that is regularly the course will be handled in a month, and your doubts will be cleared or heard at the last, right? It's not a useful one, right? That's why every fourth session is a doubt clearing session. So every 3 topics you'll have a one session as a doubt solving, so your doubts will be clarified then and there, and the classes will be handled in both English and Hindi, and RIB will be provided. So these are the 6 components which comes under plus subscription. If you are going for iconic subscription, you will have all these 6. Apart from that, you will also have, additionally, you will also have a study planner, which means it is perfectly handmade. That means customized for your own, that is based on your own previous performance. It is specifically customized for you one, right? It's not a general study plan, it's customized for the person, individual. That means if a person can spend every day 4 hours, some person can spend only 2 hours, that too in the night time, some persons can spend the time in day, right? So the study planner will vary based on the persons, how they are studying and what type of topic they are studying. It's a customized study planner. And personalized coach will be there, so they will guide you to make a perfect preparation strategy based on your own performance. They will personally guide you. And dedicated doubt clearing instructors will be there, so if you have a doubt, if you post it, immediately your doubts will be clarified. And preparatory study materials, that is study materials will be provided in a PDF format, so you can download it and you can use as your notes, and practice tests can be also be used. And study booster sessions will be there, which means before the examinations you must know few guidelines, how to sit in the examination, how to start a competitive examination, where to start, and how to handle the questions which you know very well. Because few students in excitement, if they know the question very well, without reading all 4 options, they will blindly give an answer which they are finding it first as a right. There are a lot of silly mistakes will happen. So how to handle these situations, if you don't know the answer, how to handle those questions, right? So those things will be done with the regular workshops will be given to get a how to approach the competitive examinations, right, with the essential guidelines. And personalized test analysis will be there. This is a micro level analysis that will be given, that is in-depth analysis will be given based on your performance on each question type and section, right? So you will have a micro level analysis, so you may know what is your weakness, so you can build up, that means you can improvise your problems, right? And next important thing is price hiking. Yes, from the 1st July price is going to be hiked, so which means there is another 4 days to come. Before that, if you are planning to subscribe it, make it quick, right? So or else the price hike will be there from 1st July. And not only price hike, you'll also having some exciting things, that is efficient revision via digital notes will be provided. And if you do it right now, it's completely free for you, or if you do it from July, due to the price hike, you have to pay for it, so it will be compensated in the price hike, right? So here, if you need to go for a subscription, use the code PSK20, where the referral space will be provided. Here, if you use the code PSK20, you'll have a 10% discount immediately. You can see, right, for all type of subscriptions, the 10% discount is applicable, right? And most important thing is it is applicable for both plus and iconic subscription. Hope surely it will help you for you, right? And most important thing, 3 days back this batch course, that is on 23rd June, the batch course has been kick-started. And what is special about this batch course is, right, if a student who is planning to write GATE or ESE in 2022 or 2023, which means this is the perfect platform, because you don't need to do a separate preparation plan. You don't need to go for a separate test series. You don't need to go for a separate practice series, right? So everything will be there. That is, all the separate, all these things will be included in this one batch course. That means with the perfect study planning, the batch course has been made. So you have to follow only this batch course, so that every day you'll have a 2 hours or 3 hours of classes. So you can watch those classes, and after that the classes, every week you'll have a weekly test, and numericals will also be solved in this batch courses. Previous year questions will be discussed, MCQs will be provided for a practices, right? So this is one of the super planned batch course. So you don't need to search for the courses, and everything comes under one course. That means if you subscribe to this batch course, your complete syllabus will be covered with fundamentals, theories, numericals, MCQs, everything, right? So it's being very simple, right? Okay, so you can subscribe to this batch course by using the code PSK20, which means you can access all other things as I mentioned earlier in both plus and iconic subscription, right? Okay, so the code is PSK20 to access it, right? Done. So now we are entering into the topic, that is springs, right? So here we are going to discuss about helical springs. We are going to discuss about helical springs, okay, right? As I mentioned, this is one of the simple and easy topic to score it, okay? Why? Because only these three equation is necessary for a helical springs, right? You need only these three equations to answer questions from springs. That's the very interesting part. Okay, so what is the three equations? One is shear stress, deflection, and stiffness. That's it, right? So with this three equations, you can solve whatever question which is asked in springs under helical springs, right? So the concept is very important. So remember these three equations. So shear stress, that is equal to Ks 8Pd by pi dq, which means Ks represents the Walls factor, right? Okay, and P represents the axial load. This is axial load. So why? Okay. So P represents the axial load. Why axial load in springs? Because if you take up a helical spring, right? So in a helical spring, when a load is applied, this is an axial load, that is along the longitudinal axis of this spring, right? Spring path, or we can say the helix path, helical path, right? It is axial to the helical path. But this load, this axial load is parallel. This axial load is parallel to the cross section of the spring. You can see, right? So if you cut down at this part, you can see the cross section. That is, let's take it as a circular cross section. So the cutting plane and load applied is parallel. So when cutting plane and load applied is parallel, it is a shear stress, right? So that's the simple way. That's why shear stress. So shear stress, axial load, right? And D represents the mean coil diameter. D represents mean coil diameter, and here this one represents wire diameter. Okay, right? Now the same equation, same shear stress equation can be written as Ks, that is Walsh factor 8 Pc by pi dq. So here P represents the axial load, and here the small d represents the wire diameter. And what is C? Right? C means spring index, which is d by t. Now you can see that instead of d by d, C is represented. So you can use either one of these two equations, right? You get the same answer. So axial load, mean coil diameter, wire diameter, spring index. That's it, right? Very few number of values. Same way, deflection of this axial spring. Deflection of this axial spring, the equation is 8 PD cube n GD power of 4. So here P is axial load, D represents mean coil diameter, and N is number of active coils that is used. Number of active coils. So for example, here in this spring 1, 2, 3 and 4. So we are having 4 active coils. So likewise, number of active coils, that's very important. And G represents modulus of rigidity. G represents modulus of rigidity or shear modulus. We can say it as a shear modulus type, right? Okay, modulus of rigidity or shear modulus or rigidity modulus. So all other parameters are same. That's what deflection equation. And coming to the stiffness. Stiffness is load by deflection. Stiffness represents load by deflection, where deflection equation, which is given here, only load is there. So just rewrite it and you will get the equation. Okay, GD power of 4, 8D cube n and GD 8C cube n. Right. So with these three equations, now we are going to solve the previous year questions on GATE and ESE, both GATE and ESE. Okay, right. So before going into it, another important thing is, if the springs are connected in a series or in a parallel, how to determine it and what are all the important things here. If springs are connected in a series, very important point is total load is equal to load on first spring, that is equal to load on second spring. That is, load is equal, where total deflection is equal to deflection on first spring plus deflection on second spring. Okay, this is for a series connection. And stiffness equation, where I have mentioned it here. Stiffness equation. If it is a parallel connection, then total load is equal to load on first spring plus load on second spring. And deflection, that is equal to deflection on first spring, that is equal to deflection on second spring. So which is very similar to the composite sections, where we have already discussed it, right? Which is very similar to the composite sections. Okay, right? So in the parallel and series connections, in series load is common, sum of deflection is equal to total deflection. In parallel, deflection is common and sum of load on two springs is equal to total load, and their stiffness equations where I have given here. So with these data, now we are going to discuss the previous year questions, right? Okay. So let's go for the first question. So our first question, the answer is A. Okay. So now how to find the answer for us? If a wire diameter of closed coil helical spring subjected to a compressive load which is increased from 1 centimeter to 2 centimeter and other parameters remained same, then deflection will increase. That's the question. So this is a very good interesting question and also a simple question. It takes 10 to 15 seconds to answer it. Once after reading the question, it takes only 15 seconds to answer it, but it may confuse few persons if they have not understood properly. Right, so let's do it. Deflection is equal to APDQN divided by GD power of 4. Okay, GD power of 4. Now, in this case, here the wire diameter, closed coil helical spring subjected to a compressive load increased from, the wire diameter is increased from 1 centimeter to 2 centimeter. Other parameters remain same. That is very, very important. So apart from wire diameter, if other parameters remain same means axial load is same, mean coil diameter same, and number of active turns same, and modulus of rigidity same, and 8 is a constant, we are neglecting it. So what I am doing, deflection is the inversely proportional to d power of 4, right? If other parameters are same, this is what you know, right? So we can write like this, d power of 4. Now initially it is 1 centimeter. Initially the wire diameter is 1 centimeter. Later it is increased to 2 centimeter as given here. Now what is the deflection, how deflection will increase, that's the point. So we can write like this, that is deflection 1 by deflection 2, that is equal to d1 power of 4 d2 power of 4. So 2 power of 4 by 1 power of 4, that is equal to 16. So deflection 1 is equal to 16 deflection 2. So the final component is, when wire diameter increases, deflection will decrease. That's what inversely proportional. When wire diameter increases, deflection will decrease. When wire diameter increases by 2 times, as mentioned, 1 centimeter to 2 centimeter increased by 2 times, what will happen? The deflection will decrease by 16 times. Got it? That is the outcome here. When wire diameter increase by 2 times, deflection will decrease by 16 times. That's what here we got it. Got it? So the final answer is A, that is 16 is the right answer. Right? Good. So this is a comparative question. As I mentioned, it's a comparative question. So we are having many comparative questions like this, because in the springs these comparative questions are very, very interesting. Okay, right. So let's move on to the next question. Yes, so another comparative question which is even more interesting here, right? So let's look into it. A compression spring which is made of a music wire of 2 millimeter diameter, having a shear strength and shear modulus 800 megapascal, 80 gigapascal respectively. The mean coil diameter is 20 millimeter, free length is 40 mm, number of active coils is 10. If mean coil diameter is reduced to 10 millimeter, then the stiffness of spring is approximately, that is the question. Okay, so wire diameter is 2 millimeters, shear strength is 800 megapascal, modulus of rigidity 80 gigapascal, mean coil diameter 20 mm, free length 40 mm, number of active coils 10, and later mean coil diameter reduced to 10 mm. So this is initial value, final value, right? So these two values is important. When all other parameters are same, now what is the stiffness of spring? That's the question, right? So stiffness is equal to load by deflection, or on the other case we can write it as dq. Yeah, right. Now modulus of rigidity, wire diameter 8 is a constant, number of active coils, everything remains constant, only the mean coil diameter varies. So stiffness is inversely proportional to mean coil diameter Q. So obviously here, when diameter decreases, stiffness increase. Diameter decreases, stiffness decrease. That's why inversely proportional. So in this case, diameter is decreased by 2 times, right? That is dq, 20 mm to 10 mm, decreased by 2 times. So we are rewriting it, k is equal to 1 by dq, whereas we can write it as k1 by k2 d2q by d1q, that is 10q by 20q. Okay, so if you form it, then the values will be 1 by 8. So k1 is equal to k2 by 8, right? So which means here, when diameter is decreased by 2 times, then the stiffness that will increase by 8 times. Okay, when mean coil diameter decreased by 2 times, stiffness increased by 8 times. That is the meaning. In previous, when wire diameter increased 2 times, deflection that will decrease 2 times. Here it's an opposite one, right? So this is how the comparative questions can be solved without any errors. Now I have taken around 3 minutes to solve it. Once you are familiar with this condition, right, while reading the question itself, you can easily think about that modulus of rigidity, wire diameter, 8 and number of active turns, everything will be ruled out. You can directly come to this equation, and based on the proportion of mean coil diameter, you can identify it quickly, right? You don't need to write it down everything, just 2 times, right? That's it. Just you have to write it down 2 times, the comparison. It's been very simple. So according to that, when mean coil diameter decreased by 2 times, stiffness increased by 8 times, so D is the right answer. Okay, right, great. Next question. So this is another super interesting question, and GATE 2008 question. This is GATE 2008 question. If a wire diameter of a compressive helical spring is increased by 2%, the change in spring stiffness is, what is the change in spring stiffness? That's the question. What is the change in spring stiffness? So you have to correct in 2 decimal places. So that's the question that is given. Let's take initially the spring wire diameter as D. If the wire diameter of compressive helical spring is increased by 2%. So at the initial condition, the wire diameter D1 as D. Later increased by 2%. So 1.02 D. Got it? That is 100 plus 2%. 102% by 100. 102 by 100, that's why 1.02 D. Right. Now the spring equation, stiffness equation, GD power of 4 divided by 8 dqn, and obviously the G8 mean coil diameter, number of active turns, everything is ruled out because we are calculating only for a stiffness and wire diameter. That's wire diameter alone is changing, all other parameters are constant. So stiffness is directly proportional to wire diameter power of 4. That is, when wire diameter increases, stiffness will also increase. So here wire diameter is increased by 2%, so stiffness will also increase. How much it will increase? We have to identify it. So here percentage, right? If you need to calculate the percentage of increase, so percentage of increase in stiffness, K1 minus K2 by K1 into 100. What is K1? K1 means D1 power of 4, which is D power of 4, right? It is D power of 4. What is K2? D2 power of 4, which is 1.02 D whole power of 4. Okay, right? So now you can have the values, that is K1 minus K2, or here the second value is larger. We can write, because we need only difference, we can rewrite it as K2 minus K. So 1.02 D whole power of 4 minus D power of 4 divided by D power of 4 into 100, and finally the answer you will get is 8.243%. right? So the outcome, the final outcome is, if the wire diameter is increased by 2%, stiffness will increase by 8.243 percentage. I'm writing in percentage here, right? Quite good one, good, interesting question, right? Yes. Right. So it's a GATE 2008 question. Next, fourth question. So this is quite a super good question. Most of the people, as I mentioned while starting the session, while reading the question itself, if you think this is very simple one and you'll get excited, and what will happen, you won't read all the four options. While reading the option first or second option, you may find it may be a right answer, you will pick it as the right answer and you will move on to the next question. That's where the mistake happens. So always you have to read all four options, and most important thing, you must be very cautious if the question is very simple. Okay, you must be very cautious if the question is very simple, right? You have to read it at least twice or three times, then only you will find out there will be some pinch of salt will be there in the question. So the question paper setter, always they will do these kinds of things, right? You must be very careful, right? So now coming back to the question, which is a 2016 most interesting simple question. The spring constant of a helical spring does not, very important, does not depends on, that's the question, right? And four options are given. Coil diameter, that is mean coil diameter, number of active turns, material strength, and wire diameter. So spring constant means stiffness. Spring constant means stiffness, that is GD power of 4 divided by 8 d cube N. Now here mean coil diameter, option A is mean coil diameter. Yes, we are having a mean coil diameter. So stiffness is inversely proportional to mean coil diameter Q, and about N. Stiffness is inversely proportional to number of active turns. Stiffness is directly proportional to modulus of rigidity. Stiffness is directly proportional to wire diameter power of 4. So mean coil diameter, that is already there. Yes, stiffness depends on mean coil diameter, so it is ruled out. Number of active turns, yes, number of active turns, that is also there, so it is ruled out. Wire diameter, that's also ruled out. Now most of the person think that material strength and modulus of rigidity is there, right? Then how could be the material strength, right? Yes, material strength is the answer, because you can see that material strength means shear stress, direct stress, bending stress. These are a bending strength, direct strength, flexural strength, right? These are the strength of a material. And this one, that is GKE, that is bulk modulus, Young's modulus, and Poisson's ratio, are elastic constants. They are elastic constants. So this is not a, that is elastic constant is not a strength of a material, and I can say that these are deals with stiffness of a material. These are deals with the stiffness of material. Okay, right? Good. Done. Right. So according to that, B is the perfect answer for the question. Okay, good. Yes, this is another most interesting question which is asked in the 2005 question here. Okay, so just read it a minute, this question. Okay, right. Now, let us move on to the question. A weighing machine consists of 2 kg pan resting on a spring. In this condition, the pan resting on the spring, the length of spring is 200 mm. When a mass 20 kg is placed on the pan, the length of spring becomes 100 mm. For the spring, undeformed length is mentioned as LO and spring constant is K. That's the question. Okay, so let me take it down. Right. So again, read the question and with the drawing which I have mentioned. A weighing machine consists of 2 kg of pan resting on spring. Before that, I'm reading the last sentence. The undeformed length is LO. So a spring with undeformed length, a free spring without any load. Free spring without any load is LO. Right? Now, the first statement. When a weighing machine, 2 kg of pan. So the pan is 2 kg. Okay. So let's take the pan is 2 kg of pan. Right. The pan is 2 kg. Okay, which is resting on a spring. Now the pan resting on a spring, length of spring becomes 200. The spring length becomes 200. When a mass 20 kg is placed on the pan, in the pan 20 kg is placed, the spring becomes 100 mm. That means the length of spring becomes 100 mm. So we have to calculate the free length and also stiffness. That's the question. So it's another quite good, interesting question. How? The general equation, stiffness is equal to or load by deflection. Stiffness is equal to load by deflection. Right. Where load is equal to stiffness into deflection. Got it? Where load is equal to stiffness into deflection. Now, going for the case 1. This is case 1, case 2. What is the load applied in the case 1? 2 kg. Okay, load applied is 2 kg. I'm converting to newtons, right? As per the equation, load is equal to stiffness into deflection, where load applied in the first case is 2 kilograms. So 2 kilograms converting to newtons, that is equal to stiffness, and coming to the stiffness K. And what is the deflection here? So the free length minus 200, you will get this deflection part. Got it? So in order to find this deflection, free length minus 200, you will get the deflection. Got it? Right? So free length minus 200, you will get this deflection. Now on the other hand, going to the second part. Here, what is the load applied? 20 kilograms of weight is applied with 2 kg pan. 20 plus 2. So the total load is 22 kilograms into 9.81. That is equal to stiffness into deflection, right? So stiffness into, what is the total deflection? Free length minus 100, we will get this difference. Free length minus 100, we will get this remaining distance. So free length minus 100. So now we have formed the equation. Right, we have formed the equation. So with this equation, we can solve it, right? So two variables are there. If you solve these two equations, you can get the answer of K and stiffness and free length, right? So the answer is, that is free length is 210 mm and stiffness is 1960 Newton per meter. Okay, so stiffness 1960 and free length is 210 millimeters. So the final answer, you can solve it. Okay, so this is another interesting question which is asked in 2005. So with the simple equation, stiffness is equal to load by deflection, where load is equal to stiffness into deflection. So if we take the first case, load applied is 2 kg of pan. So 2 kilograms into Newton, I'm converting 9.81. That is equal to stiffness. And deflection. What is the deflection? Free length minus 200, you will get this deflection. That is first equation. Second equation is load applied is 20 plus 2, 22 kgs into 9.81, stiffness into deflection. Deflection means free length minus 100, remaining would be the deflection. Got it? So that's the super interesting question. So that's all for the session. We will see on our next session, right? So